section 5.2, we're doing properties of rational exponents. So we've actually already reviewed properties of exponents, and we've reviewed how to add, subtract, multiply, divide fractions. We've already reviewed everything. We're putting it together. So up here is just a review again of all the different properties of exponents. For example, the very first one, product of powers. If we have the same base, and you are multiplying the same base, what do you do to their exponents? You add them, but what base do I use? The same base. And then over here we've got some examples. So if we have 5 to the half times 5 to the 3 halves, you now have 5 to the, and then you have to add 5 halves plus 3 halves. Then simplify. So those are examples that are provided to you of everything we've done. Remember, if you have power of a power, if you have a power to a power, what do you do to the exponents? You multiply them, and you put them with the same base. If you have a product to a power, you could take each individual piece to that power. Remember, if you have a negative exponent, that means to reciprocate. Remember all these rules? Okay. So let's do some examples. We're going to skip work with a partner, and we're going to go all the way to example 1A. And I will be doing it up here, and I'm recording it so you can watch the video later if you need to. So 7 to the 1/4 multiplied by 7 to the 1/2. Right away, I notice both of these bases are the same. And we are doing what operation on those same bases? Multiplying same bases. So if I'm multiplying, what do I do? The exponents. I add them. So my next step is to say same base, 7, and I'm going to have to the 1/4 plus 1/2. So I'm adding my exponents. How do I add fractions? Can I add 1/4 plus 1/2? Not the same. So what do I need to add fractions? I need like terms. What should be like to add fractions? Come on, we did this last week. Common denominator. I need them both to be the same denominator, which they are not. What denominator should I choose? So if I multiply this half, if I multiply the bottom by 2 to make it 4, then I also multiply the top by 2, because I have to multiply by a value of 1. I now have 7 to the 1/4 plus 2/4. So if I have 1/4 and I add 2 more fourths, I now have how many fourths? 3/4. Now to know if that is simplified all the way, can I reduce 3/4? Can I take 7 and factor 7 to a power? 7 unfactor does it. So then I know that this has got to be the final answer. So we want to simplify if possible, but this one does not go any further. No. Remember up here, I'm going to go right back up here. Right here. You see how important? They keep the same base, we just add their exponents. Okay, for part B, I'm looking on the inside here, and are these the same base? They're not. So I can't really multiply them together. So I'm going to go outside this parenthesis, and I'm going to say, oh, there's a power on it. It says square what's in here. So what do I do when I have a power of a power? Multiply. So I have 6, and I'm going to do both exponents multiplied by 2. So I'm going to have the 1/2 is being multiplied by 2. And then I also have 4 to the 1/3 being multiplied by 2. And then you say, well, how do I multiply a fraction times a whole number? I put 2 over 1 and have a multiply fraction. Straight across, so I'm going to get 6 to the 2 halves. Over here, same thing, put 2 over 1, go straight across, 4 to the 2/3. We can simplify that a little bit further, because what's 2 halves equal? Come on, what's 2 halves equal? Help me out. 1, thank you. So we have 6 to the first, I don't even need to write the first. So 6 times 4 to the 2/3. Are these the same bases? Then I cannot multiply them together. Can 4 to the 2/3 be simplified? Not sure. Let's see. I'm saying simplify? I don't know. Let's see. 4 to the 2/3. So we're going to do what we did last week where we take 4 and factor it down. What does 4 factor down to be? 2 squared. If you are sleeping, just remember you're more than welcome to stand in the back. I know it's hot in our room. It's so easy to want to drink that off. But if you are sleeping, you gotta pull yourself together. Stand up in the back. Use the counter if you want. Okay, so I just made 4 into 2 squared, and then I'm going to put 2/1. I'm going to multiply my fractions, and I'm going to get 2 to the 4/3. Does 4/3 reduce? No. So 4 to the 2/3 didn't reduce either. But it could in the future. I just want to show you that just in case it did. So I could either have my answer as 6 times 4 to the 2/3, or I could rewrite it as 6 times 2 to the 4/3 if I use that simplify. But either way, either answer is not more simplified than the other. Almost done. Question? Either one would be fine, yeah. Because, like, if you try to simplify it and it doesn't actually reduce, this is still fine. This one didn't simplify, so either would be fine with me. I would always just try to simplify, just in case. All right, for C, you could do C the same way we just did B. But I'm going to show you a different way, because I like this other way better. But you could do C the same way we just did B. But there's something different about C. So these are not the same bases, but they have the exact same exponent. The other one did not have the exact same exponent. This one does. Because it has the exact same exponent, I'm going to use the power of a product property backwards. I'm going to rewrite this as, let's see if you can see why I'm rewriting it this way. I'm going to rewrite it as 4 times 3, quantity to the 5th. Do you see how I'm allowed to do that? Because if I had 4 times 3 to the 5th, that would mean 4 to the 5th times 3 to the 5th. So what I did is I basically just pulled out that exponent. Why would I want to do that? Why do you think I did that? There's 2 reasons you could answer. Why do you think, Carly? Just like, take a guess. Why do you think, David? Yeah, now that it's just 4 times 3, which is 12. Okay, yeah, that's why I did that. So we'll multiply 4 and 3 by 12. Also, what do my powers do? The exponent. They multiply. So I'm going to 5 over 1 and multiply it straight across. What do I get when I multiply this straight across? What do I get? I get negative 1. I get negative 5 over 5, which is negative 1. So now can I simplify that further? Yes, because you never need a negative exponent. So what's the negative exponent say? Reciprocate. So my answer is going to be 1 over 12. See how we're putting all these rules together now? All right, D. 5 divided by 5 to the 1/3. I noticed that the big number, the base, on top and the bottom is the same. We have like bases. And we are dividing. That's what fractions mean. They mean divide. You know what the symbol means? That's a fraction. That is a fraction. That's what that is. What do you think fractions mean? Isn't that cool? They never tell you that. Okay. So anyway, so we have like bases, and when you're dividing like bases, what do you do to their exponent? Subtract them. What is the exponent on the top? 1. So we're going to have 5 to the 1 minus 1/3. So I'm subtracting my exponents. I need to subtract those, but if I'm subtracting fractions, they have to be like. Meaning what has to be like? When you subtract fractions, what has to be like? The denominators. So we're going to make 1 into 3/3 minus 1/3. We get 5 to the 2/3. Can I simplify 2/3? Can I factor 5? Like I just factored that 4? No, because that's prime, so we're done. Okay, the next one. Do I have like bases? So I can't just divide them, but the exponents on the top and the bottom are the same. So what I'm going to do is I'm going to pull that exponent out. I'm going to write 42 divided by 6 to the 1/3, and then that whole thing squared. So I pulled out the 1/3 from the top and the bottom. And that's the product of a quotient property. Not that you care. You don't have to know the names of it. Just trying to sound smart. You know what I'm saying? Okay. 42 divided by 6 now is by itself, so what's 42 divided by 6? 7. And then we've got to the 1/3, and then to the 2, which we can put over 1. Multiply those together, what do we get? 2/3. Is 2/3 reduced? No. Can 7 be factored? No. Prime. So we're done. So you were handed this packet, and you were also handed a worksheet. This is your assignment, but I want to show something to you on the back. The worksheet says to enter your final answer on Big Ideas Online. That is not going to be available to you until class tomorrow. So don't even get on yet. Just get your answers down here, and then tomorrow I'll unlock it and you can get on and see if you're right. Okay? This part won't be on Big Ideas Online. Okay, so your rest class work on this. Oh, we got 2 minutes. Why don't you do number 3? Do number 3 before you leave. Do number 3 before you leave. Wait.